आजको कुरा गरौँ इन्ट्रोडक्सन एन्ड स्कोप अफ ट्राफिक इन्जिनियरिङ ट्रान्सपोर्टेसन इन्जिनियरिङको च्याप्टर नम्बर 1 इन्ट्रोडक्सन एन्ड स्कोप अफ ट्राफिक इन्जिनियरिङ इन्ट्रोडक्सन Traffic engineering is a science which deals with proper design and layout of the route, traffic studies, analysis and engineering application for the improvement of traffic performance on route, planning, geometric design and traffic operation of route, their networks, terminals, abutting lanes, relationship with other modes of transportation for the achievement of safe, efficient and convenient movement of person and goods. Regulation, direction and control of vehicular and pedestrian traffic. Definition: according to Institute of Traffic Engineering ITE, traffic engineering is a branch of engineering which deals with planning, geometric design and traffic operation of road, streets and highways, their networks, terminals, abutting land, relationship with other mode of transportation for the achievement of safe, efficient and convenient movement of person and goods. Concerned authorities in Nepal: Ministry of Physical Planning and Transportation Management, Department of Road, Department of Transport Management, Home Ministry, Traffic Police, municipalities, DDC, UDC are also responsible to maintenance of road under their authority. DOLIDAR, Dolidar, Department of Local Infrastructure Development and Agricultural Roads. Scope of Traffic Engineering. Basic objectives of traffic engineering are to achieve efficient, free and rapid flow of traffic with minimum number of traffic accidents. Traffic engineering deals with the study of traffic characteristics, traffic study and analysis. त्यसको भित्र speed, volume may be more than capacity, it may differ, origin and destination, traffic capacity, accidents, etc. Traffic operation, legislation and enforcement measures for regulating drivers, vehicle, no plate registration, number of plate registration, and users, traffic control device, signs, signals, marking, etc. Geometric design, intersection, parking facilities, terminals, etc. Traffic and transport planning, traffic administration and management, research. ट्राफिक क्यारेक्टरिस्टिक्स यसको भित्र चाहिँ दुईटा हुन्छ रोड युजर क्यारेक्टरिस्टिक्स र भेहिकल क्यारेक्टरिस्टिक्स रोड युजर क्यारेक्टरिस्टिक्स भित्र ड्राइभर क्यारेक्टरिस्टिक्स र पेडेस्ट्रियन क्यारेक्टरिस्टिक्स रोड युजर क्यारेक्टरिस्टिक्स रोड युजर पेडेस्ट्रियन साइक्लिस्ट भेहिकल ड्राइभर street child adults talking playing on or around the road physical characteristics त्यसको भित्र पनि दुईटा छ पर्मानेन्ट र टेम्पोररी पर्मानेन्ट भित्र vision it is important factor for safety driving about 90% of information is perceived in visual human eye is the sensory organ to see and evaluate the size shape color of an object and estimate the distance and speed of the bodies. Vision is the important factor for safety driving. Hearing, important factor for pedestrian, cyclist. Strength, important for heavy vehicle drivers. Reaction to traffic situation, depends on the time required to perceive and understand the traffic situation and to take the appropriate action, that is reaction time. Temporary भित्र fatigue. Tired driver usually suffer lack of concentration and have long perception reaction time. Alcoholic drink and drugs. It affects as an aesthetic as a drug which depress the central nervous system, affecting force in brain. It can be measured by the blood alcohol concentration BAC standard for different countries. 10 mg of alcohol in 100 ml of blood is okay. Illness. It causes physical inability to drive, mental tension and lack of concentration. Mental characteristics. Knowledge, intelligence, skill, experience and illiteracy can affect the road user characteristics. Knowledge of the vehicle characteristics, traffic behavior, driving practice, rule of roads, psychology of other road user are helpful for safe driving. Psychological characteristics. Emotional factors such as attentiveness, fear, anger, superstition, impatience, etc. D. Environmental factors. Traffic flow condition, atmospheric condition, locality of driving and facilities to the driving, traffic, etc. Vehicle characteristicsमा चाहिँ तीनटा छ, static characteristics, vehicle kinematics र dynamic characteristics. Static characteristicsमा हेरौँ, weight of vehicle, height of vehicle, clearance needed for overhead structure, height of the driver seat, affect the visible distance, height of the headlight, sight distance at valley curve at night driving, clearance below chassis. Chassis will limit driveway, vertical profile, humps and dips, length of vehicle, capacity and overtaking distance, cross weight, affect the structural design of pavement and cross drainage, minimum turning angle, design of sharp curve, excluding front and rear bumpers. Vehicle type, height, weight, length, wheelbase, minimum turning angle. Passenger car, height 1.3, width 2.13, length 5.79, wheelbase 3.35, minimum turning angle 7.32. Single unit truck, height 4.11, width 2.59, length 9.14, wheelbase 6.10, minimum turning angle 12.8. Single unit bus, height 4.11, width 2.59, length 12.19, wheelbase 7.62, minimum turning angle 12.8. As per NRS 2070, vehicle specification as follows: maximum width 2.5 meter, maximum height 4.75 meter, maximum length 18 meter, maximum single axle load 100 kN. 2 छ vehicle kinematics, relationship between force and acceleration, F equal to ma. For uniform acceleration, that is a constant, force speed acceleration function dv by dt भनेको a हुन्छ. dv लाई एक ठाउँमा राखेर dt लाई उता पठायो भने हाम्रो dv इक्वल टु a dt हुन्छ. त्यसलाई इन्टिग्रेट गर्यो p नट देखि p सम्म, त्यो गर्दाखेरि p इक्वल टु p नट प्लस 80 भन्ने एउटा फर्मुला आयो. फर डिस्टेन्स टाइम फंक्सन dx by dt भनेको p हुन्छ. dx भनेको p नट प्लस 80 डिभाइड बाई 80. यो के गरेको भन्दाखेरि यो p को भ्यालु चाहिँ p नट प्लस 80 भन्ने हामीले पहिले निकालिसकेका छौँ. त्यो भ्यालु चाहिँ यता राखेर त्यो आएको. त्यहाँबाट के आउँछ त इन्टिग्रेट गर्दाखेरि x इक्वल टु p नट t प्लस 1/2 80 स्क्वायर, इक्वेसन नम्बर 2. फर डिस्टेन्स स्पिड फंक्सन x इक्वल टु p स्क्वायर माइनस p नट स्क्वायर डिभाइड बाई 2a. यो चाहिँ कसरी आएको भन्दाखेरि फ्रम इक्वेसन 1 एन्ड 2. यो p इक्वल टु p नट प्लस 80 बाट p नट को फर्मुला p माइनस 80 हुन्छ. त्यो फर्मुला हामीले इक्वेसन नम्बर 2 मा राख्दियो भने यो फर्मुला आउँछ है त. वेयर p भनेको स्पिड, p नट भनेको इनिशियल स्पिड, x भनेको डिस्टेन्स, t भनेको टाइम. For non-uniform acceleration, real world situation, necessary to relate acceleration in proportion to the speed and a specific case is to vary acceleration inversely to the speed as noted below. dv by dt equal to alpha minus beta b, where alpha and beta are constant. An equation of speed at given time t and speed p naught. यो चाहिँ हामीले इन्टिग्रेट गरेर यताउति गर्दाखेरि त्यो आउने फर्मुलाहरू हो। p भनेको अल्फा डिभाइड बाई बीटा 1 माइनस e को पावर माइनस बीटा t प्लस p नट e को पावर माइनस बीटा t। इक्वेसन अफ डिस्टेन्स एट टाइम t एन्ड इनिसियल स्पिड p नट। x भनेको अल्फा t डिभाइड बाई बीटा माइनस अल्फा बाई बीटा स्क्वायर 1 माइनस e को पावर माइनस बीटा t प्लस p नट डिभाइड बाई बीटा 1 माइनस e को पावर माइनस बीटा t। इक्वेसन अफ एक्सलरेसन एट गिभन टाइम t एन्ड इनिसियल स्पिड p नट। a भनेको dv बाई dt हुन्छ, त्यो भनेको अल्फा माइनस बीटा p नट e को पावर माइनस bt। अर्को हाम्रो लास्ट छ डायनामिक क्यारेक्टरिस्टिक्स। डायनामिक क्यारेक्टरिस्टिक्स अफ भेहिकल एफेक्टिङ रोड डिजाइन आर स्पिड, एक्सलरेसन एन्ड ब्रेकिङ क्यारेक्टरिस्टिक्स। Speed and acceleration depend upon the power of the engine and resistance to overcome and are important in the entire geometric design element. The stability and safe movement on the horizontal curves are affected by the width of wheelbase and height of CG. While vehicle is in the motion, there are several forces act on it, such as air resistance, grade resistance, rolling resistance, and curb resistance. Figure A हो air resistance. A vehicle in motion has to overcome the resistance of the air in front of it as well as the force due to the frictional action of the air around it. The force required to overcome this is known as the air resistance and is related to the cross-sectional area of the vehicle in a direction perpendicular to the direction of motion and to the square of the speed of the vehicle. Grade resistance. When a vehicle moves up a grade, a component of the weight of the vehicle acts downward and along the plane of the highway. This creates a force acting in a direction opposite that of the motion. This force is a grade resistance. A vehicle traveling up a grade will therefore tend to lose speed unless an accelerating force is applied. Curb resistance. When a passenger car is maneuvered to take a curb, external forces act on the front wheels of the vehicle. These forces have components that have a retarding effect on the forward motion of the vehicle. The sum effect of these components constitutes the curb resistance. This resistance depends on the radius of the curb, the gross weight of the vehicle, and the velocity at which the vehicle is moving. Rolling resistance. There are forces within the vehicle itself that offer resistance to motion. These forces are due mainly to frictional effect on moving parts of vehicle, but they also include the frictional slip between the pavement surface and the tires. The sum effect of these forces on motion is known as rolling resistance. The rolling resistance depends on the speed of the vehicle and the type of pavement. Rolling forces are relatively lower on smooth pavements than on rough pavements. Important vehicular characteristics are weight of loaded vehicle. Maximum weight of loaded vehicle affects longitudinal grades and pavement thickness. According to the weight of the loaded vehicle and its engine power, the limiting longitudinal value of gradient is assigned. Actual load should not exceed 8.165 tons but likely to be revised as 10 tons. Total load of any loaded vehicle of combination of vehicles should not exceed the value given as follows. IRC. W भनेको 1525 हुन्छ, यो भनेको L W equal to 1525 bracket L plus 7.3 minus 14.7 L cube, where W भनेको total weight of the loaded vehicle kg, L भनेको distance between extreme axles when it is greater than 2.44 meter. When L is less than 2.44 meter, the total load of loaded vehicle should not exceed 14,515 kg. Power of the vehicle. Power of the heaviest vehicle and its gross weight governs the permissible and limiting values of gradient on roads. Speed of vehicle. Depending upon power vehicle, loaded weight and efficiency of engine. Depends upon power vehicle, loaded weight and efficiency of engine. Fx the side distance, super elevation, length of transition curve, limiting radius on horizontal curve, vertical valley curves, width of pavement, capacity of traffic lane and control measures on intersection. Braking characteristics. Rate of retardation depends upon braking efficiency. Braking efficiency depends upon types of brakes, stopping distance, spacing between two consecutive vehicles, overtaking side distance. Braking test. When brakes are applied to a vehicle in motion, friction comes into action between the tire and the road surface and the vehicle comes to stop. Friction mobilized depends upon the roughness of the surface, whether it is wet or dry. A smooth wet surface has low friction, whereas a dry rough surface has high friction. Braking distance L is equal to p square by 2g of f भनेको v square by 2gl हुन्छ, where p भनेको इनिशियल स्पिड मिटर पर सेकेन्ड, l भनेको ब्रेकिङ डिस्टेन्स, f भनेको एभरेज हिट डिस्टेन्स. हामीलाई थाहा छ फर्मुला f इक्वल टु ma. क्यापिटल F भनेको W इन्टु स्मल f अनि वेट भनेको mg थाहा छ. सो mबाट m को भ्यालु W बाई जी हुन्छ. सो यहाँ W a बाई जी भयो, W काट्यो, f इक्वल टु a बाई जी. सो अब न्युमेरिकल हो, हेर्न सक्नुहुन्छ. सो न्युमेरिकल छ. A truck traveling at 40 km per hour. A truck traveling at 40 km per hour is approaching a stop sign at time t0 and at a distance of 20 meters. The truck begins to slow down by decelerating at 4 meters per second. Will the truck be able to stop on time भनेको छ. सो अब सोल्युसन गिभन इनिशियल भेलोसिटी p0 भनेको 40 km per hour, 40 into 1000 divided by 60 into 60, 11.11 meter per second. Distance x is equal to 20 meter. Decelerating acceleration is 4 meter per second square. That is acceleration equal to minus 4 meter per second square. Final velocity छैन. सो हामीलाई थाहा छ फर्मुला p इक्वल टु u प्लस एटी. p भनेको 0 भइहाल्यो अनि u भनेको माइनस a बाई t भयो अनि t भनेको माइनस u बाई a भयो. त्यहाँबाट हामीले फर्मुला लाग्दाखेरि त्यहाँबाट हामीलाई भ्यालु राख्दाखेरि 2.77 सेकेन्ड आयो. अर्को फर्मुला हामीसँग के छ भन्दाखेरि s इक्वल टु ut प्लस हाफ एटी स्क्वायर, 11.11 इन्टु 2.777 इन प्लस 1/2 माइनस 4 इन्टु 2.777 को स्क्वायर गर्दाखेरि 15.429 मिटर आउँछ. सो 20 मिटरसम्म चाहिँ 20 मिटरसम्म उ गर्न पायो भनेपछि हाम्रो कति आयो 15 आयो भनेपछि सो hence the truck will be able to stop on time. अर्को छ vehicle traveling at 55 km per hour was stopped within 2.5 seconds after application of brakes. Calculate the average skid resistance भनेको छ. Speed of vehicle 55 km per hour, 55 into 1000 divided by 60 into 60, 15.278 meter per second. टाइम भनेको 2.5 सेकेन्ड. एक्सलेरेसन भनेको v बाई टी, v इक्वल टु u प्लस एटी हुन्छ. अनि त्यो चाहिँ अनि हाम्रो इनिशियल भेलोसिटी चाहिँ छैन, त्यही भएर यहाँबाट भ्यालु आउँछ 6.111 मिटर पर सेकेन्ड स्क्वायर. एफ भनेको a बाई जी 0.623 भनेर आयो. अब अर्को क्वेसन छ. अ ड्राइभर ट्राभलिङ एट 50 km behind another car and he decides to pass it and accelerate it if the rate of acceleration is given by the relation dv by dt equal to 1.2 minus 0.015 p, where p is the speed in meter per second and t is the time in second. Find the rate of acceleration after 8 seconds. Time taken to attain a speed of 100 km per hour. Distance traveled by the car in 160 seconds. Solution. Initial velocity v0 भनेको 50 km per hour भयो, 50 into 1000 divided by 60 into 60, 13.89 meter per second. dv by dt हामीलाई दिएको छ 1.2 minus 0.015 p. Comparing equation with dv by dt equal to alpha minus beta b. Then alpha भनेको 1/1.2 भयो, beta भनेको 0.015. अनि हामीलाई निकाल भनेको छ रेट अफ एक्सलेरेसन आफ्टर 8 सेकेन्ड. सो रेट अफ एक्सलेरेसन आफ्टर 8 सेकेन्ड भनेको हाम्रो फर्मुला छ a इक्वल टु अल्फा माइनस बिटा p नट e को पावर माइनस bt. यो अनि 1.2 माइनस 0.015 इन्टु 13.89 इन्टु इको पावर माइनस 0.015 इन्टु 8 गर्दाखेरि 0.879 मिटर पर सेकेन्ड स्क्वायर आयो। अनि अर्को हामीलाई के भनेको छ भन्दाखेरि अर्को हामीसँग इक्वेसन छ वी हेभ इक्वेसन p इक्वल टु अल्फा बाई बिटा 1 माइनस इको पावर माइनस बिटी प्लस पी नट इको पावर माइनस बिटी। p को भ्यालु 27.778 मिटर पर सेकेन्ड इक्वल टु 1.2 डिभाइड बाई 0.015 1 माइनस इको पावर माइनस 0.015 टी प्लस 13.889 इको पावर माइनस 0.015 टी। p भनेको 100 किलोमिटर पर आवर दिएको छ, त्यसलाई मिटर पर सेकेन्डमा कन्भर्ट गर्दा 100 इन्टु 10 को पावर 3 डिभाइड बाई 60 इन्टु 60 गर्दा 27.778 मिटर पर सेकेन्ड स्क्वायर आएको यो भ्यालु। यसलाई क्यालकुलेट गरेर 15.722 आउँछ। अनि हामीसँग वी हेभ टी इक्वल टु 160 सेकेन्ड एक्सको भ्यालु निकाल्नु पर्ने अल्फा टी बाई बिटा माइनस अल्फा बाई बिटा स्क्वायर 1 माइनस इको पावर माइनस बिटा प्लस पी नट बाई बिटा 1 माइनस इको पावर माइनस बिटा। यो भ्यालु चाहिँ 160 सेकेन्ड राख्नुपर्ने हो यहाँ चाहिँ, सरी यो चाहिँ मिस्टेक भएछ।